this video, we're going to talk about how you can create your custom images using Dockerfiles. So I talked earlier about how images are sort of like recipes. Well, a Dockerfile is going to be like the recipe, but it has all of the instructions laid out for how you're going to create your container. So the steps that you need to do in order to create a Dockerfile are first that you need to create your own working directory. So the working directory is just going to be a directory that has all the files that you want to have packaged into your image. One thing to note is you don't want to make the working directory something like your root directory, because when you try to build this image, it's going to try to index everything. It's going to create all sorts of security vulnerabilities if you tried to just use your root directory. So be sure to make a specific space for this Docker file. Then you're in that directory, you're going to put a file with the name Dockerfile with a capital D, and in it you're going to have all of your instructions. And then you just use the podman build command in order to create your image. So like I said, Dockerfile is just a simple text file, and each line is just going to have an instruction and then arguments for that instruction. And we'll take a look at some examples in a second. One thing to note about the Dockerfile is that each instruction is executed sequentially. So it's really important to understand what is happening when. You don't want to just randomly put in all of your yum installs and then put all your copies in without really thinking about, okay, these are going to be happening in order. So be very deliberate about the order in which you put your instructions. Okay, so here's a sample Dockerfile as promised. Just stepping through some of these instructions, the items in bold on the left that are in all capitals, those are the types of instructions. So the first instruction you'll see, well, the first thing you'll see is the comment line. So that is how you put comments in a Dockerfile. It's a good idea to comment lines if things might be a little unclear. We really want to make these Dockerfiles very readable. They're meant to be read by other people. So the first instruction we see after the comment is the from instruction. So that is going to set what our base image or parent image is going to be. So think back to that MySQL image that I just deployed. The MySQL image was inheriting a rel parent image. So what that means is we were installing rel, and then on top of that we were installing MySQL. So in the case of this Dockerfile, this is an Apache Dockerfile. You can skip down, you can see in the description it says this is a custom Apache container image. We are installing rel, and then we are building Apache on top of it. The next instruction is label, and label is just a simple key value pair that you can use. This is helpful for later on if you're wanting to filter and search through your containers. This is just metadata. It's not going to have any effect on the outcome of what's installed or what your container looks like. Same thing with maintainer. That's also just metadata. It's a good idea to put your name and email address there in the Dockerfile. The run command is where you're executing, the run instruction, excuse me, is where you're executing commands. So in this case, we are doing a run, and we're just doing a yum install of Apache. Expose is communicating to the developer which port is being exposed. 80 is the default port for Apache, so it's important to note that expose doesn't actually do anything. It really is just more metadata. So you're communicating to the developer, hey, you need to make sure that you're aware that this is the port that we are going to be listening for. env is setting environment variables. So any environment variables you configure here are going to be propagated down into your container. The add command is able to put files from remote places inside of your container. So in this case, this example is just pulling a PDF and then copying it into the var www HTML directory, which is where the Apache server is serving files. Similarly, the copy command can also put things from the host directory into the container. The difference there is that add is able to do remote files and is also able to untar files and unpackage files. So if you have a tar you wanted to copy in the container, if you use add, it'll help untar that file. The user command is what you would use to specify which user you want to run the subsequent commands as. As I mentioned, all of this is happening sequentially in order. So the user command, if you put that before the add or the copy or the run, it would try to execute those commands as the user Apache. In this case, it's happening afterward. So that means the entry point is going to be run as the user Apache. Okay, entry point, again, containers are isolated processes. And in this case, this container is going to be running the HTTPD. Command provides the parameters for the entry point. So the only difference here is that we are running this in the foreground. Just a little bit more about command and entry point. I realize that these concepts can be a little bit confusing. But like I said, entry point helps define Dockerfiles and their images and the containers they create as executables. So by default, an entry point is specified as bin/sh-c. So it's not required that you put in an entry point. It's just a good idea. Command is going to provide the arguments for that image. So if you don't have an entry point, but that you placed a command, something like a ping or something like that as your command, it's still going to execute just normally as a ping. The one advantage is that you can overwrite that command and that parameter by passing in a command on your run instruction. So this is nice because it helps make your containers really flexible. So it's just a good idea to have an entry point and command if you can, because you are then able to overwrite that command as you need. Image layering. So another important aspect of Dockerfiles is that you want to be very aware of how they are written, and you want to make them as readable and as efficient as possible. So one thing to know is that every time you do a run instruction, like for example, down here we're running 3 yum run instructions in a row. So what's that doing is that it's creating a layer to build that image every single time we do a separate instruction. It can be a minor change, but if your images get bigger and bigger, this quickly helps expand the size to be much bigger than you would want it to be. It's not unheard of for images to reach up in the 800, 900, 1 gig, 2 gig sizes. So you really want to be cognizant of keeping your Dockerfiles as slim as possible. So we can get around that if we use these double ampersands. So what this is doing is allowing us to use a single run instruction, but we're able to run multiple commands. So this is great because we ultimately end up with 1 layer compared to 3 layers in the previous example. One thing about that, however, is that it's not super readable. So again, we want our images to not only be very efficient, but we want them to be readable as well. So we can get around that by using these backslashes here. And that will allow us to both stack our run instructions so that they look just as good as the very first example, but they're also going to be efficient and only create a single layer. That kind of formatting works really well for labels and environment variables too. You'll very often see that there's a lot of labels stacked right at the top of your Dockerfiles, and the same thing for environment variables. It helps a lot to make it more readable if you put them onto new lines. So once we have written our Dockerfile, we can use podman build to actually create that image and have it stored locally. So the syntax in order to do that is to run podman build -t, we'll give it a name, colon, and give it a tag, and then you point to the directory where the Dockerfile is located. One of the things you'll see very often is that most people are doing podman builds within their current directory. Just be aware that oftentimes that current directory is represented as just a single period. So just be aware, a lot of times when I'm copying down commands, I sometimes forget to put that single period. But it's very simple just to build the Dockerfile into an image once you have that available. Okay, so let's go ahead and hop into a demonstration, and I'll show you how to build a Dockerfile. Okay, so I am here in my working directory, which is called Dockerfile create. And I am going to open up a VI session and create a Dockerfile. So the first thing we want to do is we want to specify our parent image, in this case rel7, and I'm going to use the tag 7.5. And we're going to be creating an Apache image here, I should mention. Okay, I want to specify the maintainer, which is me, Zach Gutterman. Here's my email. You can send me compliments or hate mail if you would like. And we're going to add a label. Remember, this is just metadata at this point. So these are just simple key value pairs. So the description, say a custom Apache image. Okay. I'm going to do an add. This is a file that I already have ready to go, and all this is doing is configuring my Yum repository that's going to work in this classroom environment. But what I'm doing is I'm copying this training.repo file that's in my working directory, and I'm copying it into my container. And I want to do this first because, remember, this is all happening sequentially. So my next instruction is that I'm going to do a yum install of Apache, and I'm doing a double ampersand, and I'm going to do a yum clean all. Remember, this is two yum instructions, or two yum runs that are happening. I'm only using a single run, and that's going to make it so that I only have one added layer to my image. Okay, and I'm going to do a further customization here. I'm going to do a run echo hello from Dockerfile, and I'm going to put that in the user share HTTPD no index index.html. This way, when we actually hit the web server, we should see this message that will confirm that our server has indeed been customized. Okay, and then I'm going to run an expose 80. This is going to expose the port. Actually, it's not going to expose the port. This is just metadata, which says that the port is exposed. So again, it doesn't actually do anything, but we know that Apache by default runs on port 80, so we're letting other developers know the same. And we are going to put an entry point that is going to specify HTTPD, and I'm going to add some parameters. Okay. All right, let's just double check to make sure everything looks good there. Entry point, oh, probably want to put a space here. Entry point expose run. Okay, that looks good to me. So let's give it a shot. See if it works. Okay, so we're already in our directory, and I'm going to run a podman build -t. I'm going to name it do80/Apache, and I'm using that period to say that I'm in this directory already. So you know that my Dockerfile is here, and you can go ahead and try to build it. Okay, so once that returns, if we run sudo podman images, we're going to see not only do we have our Apache image, but we've got a Rails 7 image, because remember, that is our parent image, so podman knows that it needs to download that image as well, in addition to our custom do80 Apache image. Okay, so now we can try to run it and see what happens. I'm going to give this the name lab Apache. I'm going to run it in the background with the -d option. I'm going to use something we haven't seen yet before, which is -p. That is a port forward. All that's going to do is enable me to access the web server from the local host. So I'm forwarding port 10080 to port 80 within the container. Remember that the container is running on port 80. So if any network traffic that's going to localhost, or to, I guess, anything on port 10080 is going to forward traffic into port 80 within the container. And then do180 Apache is the name of our image. Oh, I'm sorry, it's do080. Okay, so sudo podman ps. Okay, we see that our Apache container is up and running. So let's give it a shot. I will try and do a curl. Port 10080. Remember, that's the port that we're forwarding from. Hello from Dockerfile. Okay, great. We did it. So that concludes this video, and I'll see you in the next video, and we'll start talking more about OpenShift.